Okay, so now we're moving on to section 16.1. And in 16.1, we have question numbers 5 and 16. So here's question number 5. It says square B is a dilation of square A. So you have to read the question really carefully, okay? Square B is a dilation of square A. What that means is you first start with square A, okay? And then you dilated it and it became square B. A lot of you would get this question wrong because you don't understand if you're supposed to go from A to B or B to A. So square B is what? A dilation of square A. That means you had to dilate square A and then you got square B. Okay, so what is the scale factor? We already know that we have to express that in fraction form, right? Square A is all 35. This is 35, this is 35, 35, 35. So then, what that means is we're going from 35 units, square A has 35 units, and then all of a sudden we went to square B, which has 28, 28, 28, 28 units, right? Okay, so let's think about this. We went from big to small, didn't we? Okay, so then we know we have to either use 35 over 28 or 28 over 35. Now let's use common sense. If you want to go from big to small, you're going to have to multiply by what? Well, if you multiply by any number bigger than 1, you know it's going to get even bigger. It's kind of like if you have a 2 and then you multiply it by 3, you're going to get 6. But if you go 2 and then you multiply it by a number less than 1, like say for example 0.3, you're going to get 0.6. So you started with 2 on both cases, but you ended up with a bigger number when you multiplied by a number bigger than 1, and you ended up with a smaller number when you multiplied by a number smaller than 1, okay? So what I'm trying to say is, in order for you to go from big to small, you have to multiply by number smaller than 1. So what is smaller than 1? This or that? Obviously, this is top heavy, so that's bigger than 1. So this is your answer, except you gotta simplify. So go ahead and divide the top and the bottom by 7, and you'll get 4 over 5. And so what is your answer over here? Yes, your scale factor is 4 over 5. In order for you to go from big to small, you have to multiply by a number that's smaller than 1. This is not it, because then this becomes 5 over 4, and that's bigger than 1. That's 1.25, right? So no. All right. I don't want anybody getting this question wrong. It is so easy, and yet a lot of you get it wrong. And don't forget to simplify, okay? Now let's move on to the next question, and that would be question number 16. Module 16 is a very easy module, right? Okay, you work at a photography store. A customer has a picture that is 4.5 inches tall. The customer wants a reduced copy of the picture to fit a space of 2.7 inches tall on a postcard. What scale factor should you use to reduce the picture to the correct size? Okay, this is a real life problem, right? Isn't that really cool? I like questions like these a lot. Okay. So the actual picture is 4.5 inches tall, and it doesn't tell us how long this side is, right? We don't know. It only tells us how long this side is, okay? But this person now wants to reduce the size of the picture to fit a small space. And in this postcard, you know how a lot of people put pictures in their postcards? Yeah, they do that these days. But anyway, he now wants this 4.5 inches to be shrunk to 27 inches. And so, of course, we have to work on dilations. We cannot just, cut it and just show this side and then keep the length the same or anything like that, right? We have to make sure that everything is proportional. Okay, so we have to reduce the whole thing, the height, also the length or the width, the height and both the width, or the length and the width, okay, however you would say. I like to say that. So what is the scale factor you should use? So we're doing the same thing again. So we're going from this big picture to the small picture in the postcard. So again, we're going from big to small. So we need to use a number that's smaller than 1. This is the exact same question as the previous one, right? So we're going from 4.5 and then we're moving to 2.7. So you can either have 4.5 over 2.7 or you can have 2.7 over 4.5 that you can multiply. This is bigger than 1. This is not. So that would be your answer, except oh, we have a predicament, right? We cannot have decimals and fractions all at the same time. So that is when we have to go to our handy dandy calculator, right? And does it say anything else? Oh, they give you fractions, okay? But no, if you put that fractions in, you're not supposed to have decimals and fractions all together at the same time. Now pay attention to unit. This is inches and inches, so that's good. It's not like we have to change inches to feet or anything like that. So what I'm gonna do is I'm gonna go into my handy dandy calculator. So let's go there together. And so I always tell you my favorite is Desmos, right? So we're going there and I'm going to put it in 2.7 divided by 4.5. And then it tells me right away, oh, it's 0.6. We can actually express 0.6 in fraction form. That's why that question was like that. But on my test, you just put 0.6 and I'm very happy with that. Okay, so let's go back. 0.6 is actually 6 over 10, which simplifies to 3 over 5, okay? And that is correct, but again, let me go back to what I was doing. So then there you go. I plugged it into Desmos and what I got, as you all remember, is 0.6. And then I already plugged in my answer, which is 3 over 5. And you might be like, Miss Choi, how did you get 3 over 5 from 0.6? Well, because 0.6 is the same as 6 over 10. And then I divided top and bottom by 2, which gave me 3 over 5. But on your test, if you just give me the decimal form 0.6, that's gonna be good enough for me, okay? Whenever you go from big to small, just remember you have to multiply by a number smaller than 1. And that is the most important thing. Now let's move on to 16.2. So now we're at 16.2, question number 4, okay? So this is question number 4. As you can see right here, this is question number 4 in your evaluate section. And it says determine whether the two figures are similar using similarity transformations. Complete the explanation. Okay, so let's see. You don't really have to complete the explanation. You gotta explain it anyway. So determine whether two figures are similar. So we have to try and remember, what does similarity mean? Okay, so when we talk about similarity, a lot of you get confused with congruence, right? Similarity means they look similar. That means different size, okay? But it still has to be the same shape. The circle cannot turn into a square, okay? That they are not similar at all. It has to be the same shape, but maybe like the small square, all of a sudden turned into a big square. That's similarity. And then we talk about congruence, and congruence basically means it's the same thing. So that means same shape, same size. So then some of my students were asking me when they were taking the Module 16 test, Miss Choi, if two shapes are congruent to each other, are they also similar? My answer is yes. If two shapes are the same size and the same shape, well, it's the same thing. Similarity means you can have, we're talking about different sizes, but this time your ratio for similarity could have been 1 to 1. So the size could have been the same. So by definition, when we talk about similarity, we only talk about preserving angle measures, right? And then we talk about the ratio of the sides being the same. So our ratio of sides in this case could go from 1 to 2, right? Or in this case, our ratio of sides can go from 1 to 1. So there's no change. So when two shapes are congruent to each other, they are also called similar to each other, okay? So similarity is like a big definition, and underneath similarity, there is also congruence, okay? So I just want you to understand that. All right, so now let's continue on with our question. As you can see, look, I'm counting the sides. This side is 2 units long, right? This side is 2 units long. And this one is also 2 units long, right? And then as you can see over here, this length over here is 1, 2, 3, 4, 5, 6 units long, and that's the same thing over here. I have no doubt because the two legs of the right triangle measure the same thing, both of them. I have no doubt that this third side, the hypotenuse, actually measure the same. Okay, so I can do the calculation. 2 squared plus 6 squared. And then you gotta find the square root. That's the distance formula. So 4 plus 36, and that equals square root of 40. And that's the same thing here. So I'm just gonna write the length over here just so I know what it is, just because, I have to. And right away, we already know that all three sides measure the same. And we already know that both are right triangles because of this angle right here, as you can see, right? So I already know that these two triangles are congruent to each other, okay? But we have to explain why they are similar, and in order for us to explain that, we gotta use our definition. So now let's take a look down here. The angles are congruent, okay? So let's go down. The angles are congruent or the same since similarity transformations preserve angle measures. Okay, preserve angle measures. What that means is angle measures stay the same, so angles stay the same. And that's why triangle UVW and GHI, these two triangles, are similar. Wow, this is like the easiest question in the world. And I really hate it when the questions are weird and then the textbook gives you, the wrong answer. So I just want you to know that question number 4 in 16.2, the question in the textbook, the answer is wrong, okay? So trust me, those two triangles are congruent to each other. I don't know what happened. I'm going to go ahead and report this to the textbook company. So don't worry. When you go online to your textbook for 16.2 question number 4, I solved many different questions and they all told me that I am wrong. But as you can see, every single triangle are congruent to each other, so they are similar to each other because the angles are the same. Okay, so don't worry if you go into your online textbook and then you say, but Miss Choi, I put in the correct answer and it told me I'm wrong, because they are congruent, and so that means they are similar to each other. In the textbook, they try and claim that the angles are not the same measure, but they are. Okay, so now let's move on to question number 18. All right, so question number 18 says, which of the following is a dilation? This is a really easy question that I'm giving you. I want you to understand when we talk about dilation, I told you it has to be the same shape but different size, right? So let's think about this. What if you had a square like this? This is a dilation. Because what that means is I multiplied both this side and that side and that side and that side by the same number to create that. But what if you only multiplied the height? If you only multiplied to the y, then this length would be the same, only the height will change, right? And this is called a vertical stretch, okay? Now, what if you had the same square, but then you left the height alone, and then you only stretched to the side by 2? Well, as you can see, you are pulling it sideways, right? So this is basically called a horizontal stretch. And what you have to know is that a dilation is not a stretch, okay? A dilation is not a stretch. A dilation always maintains the same shape, which means you have to stretch both along the horizontal axis and also the vertical y-axis, okay? So then obviously when you look at your options here, if you're only multiplying to the y, okay, you're only pulling it up and down, so that would be a vertical stretch. If you look at B, well, you're multiplying, but you're multiplying both sides by different numbers. So This is a vertical and a horizontal stretch, but definitely not a dilation. So over here, look at this. You're multiplying both the x and the y by the same number. You're pulling it both sideways, okay? This is the x-axis and that's the y-axis, and up and down by the same amount. And that is the correct definition of a dilation. As you can see, y minus 4 means you have a shape and you bring it down by 4, right? And then over here, you're subtracting both x and y by 4. That means you have a shape. And then x minus 4 means you move it to the left by 4. And then y minus 4 means then you bring it down by 4, right? So I want you to understand what every single rule means. But your answer is obviously C. Okay, so again, let's check our answer. Make sure that that everything is working fine. Okay, now let's go ahead and move on to 16.4, and I'm gonna be done. I'm just going to do module 16 with you today. Okay. Okay, so now we're in the last section for module 16, and that would be 16.4, Aa Similarity of Triangles. A lot of you were confused in this section, so hopefully for this module 18 cumulative test, you have a clear understanding. So there you go. Determine whether the two triangles are similar. If they are similar, select the similarity statement. So again, don't forget similarity, right? What does that mean? We talked about this. They need to have the same angle measure, okay? And then the ratio of sides have to be the same, okay? And it has to be, like we talked about dilation, right? It has to be the same way. We have to stretch both sideways and up and down by the same number for all the sides, okay? And they need to have the same angle. But we learned about Aa similarity, right? And there's also SAS similarity, and all that good stuff. But you'll be able to see the selection when I click on this down here. But let's see what the question gave us, okay? The question has given us, oh, you can see the little arcs over here. That means that those two angles measure the same. But other than that, they didn't give us any other information. They didn't tell us how long this is, how long that is, nothing. All we have are the two angle measures, okay? So what we're gonna do is now we're gonna use our brain to try and figure out the other stuff, okay? So quite honestly, we can't figure out anything else. But we do know something, don't we? This angle here and that angle here, what are those called? Okay, those were called vertical angles, okay? And for those of you who forgot, they are opposite angles and they are congruent to each other, okay? So now we have one pair of yellow angles that measure the same, and then another pair of red angles that measure the same. Oh, are we talking about A and A? Yeah, we have one pair of angles that measure the same and another pair of angles that measure the same. So then, are they similar to each other? Yes, they are. Because of what? Because of the Aa similarity statement. And that was it. Isn't that quite easy? Because of the Aa triangle similarity theorem. I just want you to know there's also the SAS triangle similarity theorem and the SSS triangle similarity theorem. So in case you don't understand, I will go ahead and explain to you really fast. And so look, and again, when you say they are similar to each other, we use the little squiggly mark, not the squiggly with the equal sign. That means the same, congruent, okay? So ACB, let's go. This order is important. ACB. So you started with the yellow angle, went to the red, and then B. So then you have to do the same thing. You have to start from E, and then go to the red angle C, and then D. So it has to be ECD, okay? So see, ECD. That order is quite important. So let's make sure we check our answer correct. So you can go here and study on your own. And then I just want to explain to you a little bit about SAS and SSS triangle similarity theorem. What SAS means is, you know how in this question over here, we already knew that these two angles measure the same and these two angles measure the same? Well, we talked about two angle pairs. That's why it was AA. Uh-oh, wrong color. But anyhow, with SAS, that would be like if they gave us the measure of this side and that side. and of course I'm not gonna be accurate here, but let's say this is 1 unit long, and this is, let's see, 1, 2, let's say this is like 4 units long. Okay, so then they gave us one pair of sides, the length of one pair of sides, and the ratio is what? 1 to 4. You have to multiply to get that. And then let's say that they also gave us another pair of lengths. And this time they gave us this one, and let's say that this was 1.5, and they gave us the length of this one. And let's say that was 6 units long. Okay, and let's pretend that they didn't tell us anything about these angles right here. So then based on the information we have two pairs of sides, this 1.5 and 6, okay, and that is one side here. And then we have the vertical angle, and that would be the middle angle that's stuck. And then the third would be this side over here, the yellow lines, right? We have those pairs. So then we're like, oh, we can use SAS, but before we can say yes, we can use SAS, we gotta try and see if the ratio is the same. So let's see, this is 1 to 4. How did I get the 4? By multiplying 4 to 1. And so the ratio here is 4. You have to dilate it by a factor of 4 because you're making it bigger, right? But then what if I go from 1.5 to 6? When I multiply 4 to 1.5, am I going to get 6? Well, yes, you do. So then the ratio is the same. So again, similarity means the ratio of the sides. Ratio of the sides are the same. And in this situation that I have created for you, the ratio is 4. And that's why we can say that the two triangles are similar because of the SAS similarity theorem. So obviously you can figure out that SSS is when you have two triangles and the question is giving you all the lengths of all three sides and only all three sides. And then when we calculate the ratio, it's all the same. Okay? Because you don't know which question is going to show up. Instead of me giving you the AA, I could give you the SAS or the SSS. So please make sure you understand what to look for. Okay? Now finally, we're approaching our last question. Question number 11. There you go. This is 16.4. It says, show whether or not each pair of triangles are similar. Complete the justification of your answer and select the similarity statement if the triangles are similar. Oh, okay. This is just like the other one that I was explaining to you. Obviously, we can see that they haven't given us anything except for the three sides. So I'm guessing that is the SSS similarity statement, but we gotta check something, right? What is it? The ratio of sides. Yep, that's very important. So what we're gonna do is look at the ratio. It says AB is on top, D is at the bottom. So we're gonna measure this first, which is 16, and then we're gonna go with DE next, right? And that's 24. So let's go ahead and simplify it. I can divide the top and the bottom by 8. So that's 2 over 3. So then we have to make sure that the ratio of sides are the same for everything. Well, obviously we don't have to check AC and DF because they're the exact same. It's going to be 16 over 24 again. But then let's go ahead and check the other side, which is going to be BC and EF. All right, so BC is 5. So 5 on top because we started with this triangle in the beginning, right? And then in this other, oh, this is an equilateral, no, isosceles triangle, right? Oh, I made a mistake. So there's 8. Oh, can you simplify this any further? No. I see a problem here. Do you see the problem? Yeah, look. The ratio for the two sides over here and then the base are not the same. What did I say? The ratio of the sides have to be congruent. They have to be the same, okay? So the ratio for AB over DE is 2 over 3. Let me just go. Okay, so I'm gonna put in my answer. It's 2 over 3, and then BC and EF was, we just did this, 5 over 8, right? And so ABC and DEF, are they similar? by the SAS. Even if they were similar, it's not by SAS. It has to be SSS because we see 3 pairs of sides. There is no information on one angle in between. So anyhow, our answer is are not similar. And then it says that my answer is wrong, but my answer is correct, right? BC over EF. And it says look again at the ratio EF over CB. But as you can see over here, they don't even have that. This is BC over EF, not EF over CB. So again, in this section, I remember telling you guys that there's a lot of mistakes in the textbook. So please do not get stressed out over the wrong answers in the textbook. That's why Miss Choi made a video so you know for sure what the correct answer is. The 2 triangles are not similar, and the reason why is because the ratio of all 3 sides are not equal to each other, and the only possibility that we can have when we say that the 2 triangles are similar to each other has to be side, 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 because we have no information on what the 3 angles measure, and even if we use our brains, there's no way we can figure out if they measure the same. Okay, all right, so now we are ready. Module 17 and 18, I'm not doing videos because I have made many videos for Module 18 and 17. We spent a lot of time in class working together. Okay, so happy learning. I wish you the very best. Don't forget, this goes into your progress report card grades. Goodbye.